Welcome to Math 120, Chapter 2.1, Introduction to Set Theory. This video is not intended to be a substitute for reading the book, but as a supplement to the book. So you should have first read over Section 2.1 before watching this video. Upon completion of this section, you should be able to understand the following. Define a set. Write sets three different ways. Define the empty set. Find the cardinality of a set. Decide if two sets are equal or equivalent. At times, you should pause the video and try to answer the problem, then restart the video. A well-defined set is a collection of elements such that we can objectively determine what is a member of a set. So a very important term here, or statement here, is that we can objectively determine if something's a member, meaning you and I would not disagree if something is or is not a member of a given set. Based upon our definition, would you consider the collection of large trees to be a set? The word large is not well defined. Does large mean 9 feet, 10 feet, 100 feet? We don't know. So this is not a set. The collection of trees taller than 10 feet. Is this a set or not? Well, being taller than 10 feet is something we can measure. So yes, this is well defined. And so it is a set. Students that did well in the course, is it a set? Well, did well is not well defined. Does that mean passing? Does that mean getting at least a B? Does that mean getting at least an A? It is not a set. We typically use uppercase letters like A, B, C to represent sets. For example, for our set we have up here, the collection of trees taller than 10 feet, we could say let A equal to the set of trees taller than 10 feet. So any place I refer to A refers to this set. A set containing no elements is called the empty set and is typically represented by using the symbol given right here. So this symbol refers to a set that is empty. The symbol epsilon is used to indicate an element of a set. For example, this statement right here indicates 5 is an element of the set B. Now, we know of no other element that is or is not a member of B. The only thing we can conclude from this statement is 5 is an element of B. The symbol not an element, so notice we have a line through it, is used to indicate not an element of a set. So down below here, this statement here would be saying 5 is not an element of B. That's the only thing, again, we can conclude. We don't know if 4 is in B. We don't know if 1's not in B. The only thing we know is 5 is not an element of B. There are 3 ways to represent a set. The descriptive method, we describe what elements the set consists of. You have to be careful here because when you try to describe something, remember it has to be well defined. For example, let A equal to the set of natural numbers between 1 and 7. Just to remind you, a natural number is the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. The roster method, we list the elements that are members of the set. Note elements are separated by commas and enclosed by curly braces. 2 important statements here. When we list the elements of the set, we must separate them by commas, and they must be enclosed in curly braces. For example, let A be the set consisting of the numbers 2, 3, 4, 5, and 6. So if you think about it, this set here we just described is the same as the set above that we described. Well, this set we listed the elements, right? That's what we mean by roster, listing the elements. Set builder notation. We use a variable and some sort of algebraic description of the elements in the set. For example, we're going to say A is the set that consists of natural numbers between 1 and 7. So this is the way we'd say it. X is a number such that X is a natural number and X is between 1 and 7. So I'm actually describing the same set 3 different ways. Descriptive, describing it. Listing the elements, the roster method. And then kind of a algebraic description of it. Typically, you can use a more descriptive pattern, but this is the one that's kind of hard to say. You're just going to have to read it. Just keep in mind that right here, what we're saying is X is such that it satisfies the condition here on the right side of that vertical line. The cardinality of a set, B, is the number of elements in the set. So if I'm asking you for the cardinality, I'm asking you to count how many elements are in the set. We'll also indicate this by the following notation. This notation does not refer to multiplying n to b. It simply says the number of elements in B, the cardinality. For example, suppose we have the set A given here. Can you tell me the number of elements in A? 5. Given a set A here, can you tell me the number of elements in A? Well, we have the 3 dots right here, which you have to understand simply means the pattern on the left-hand side is being repeated, and we're going to go all the way up to 12. So apparently we're counting the even numbers from 2 to 12. So we have 2, 4, 6, 8, 10, 12. We have 6 elements in this set. In this one, we're describing our set using the set builder notation. We're counting the numbers x such that it's an integer and it's between 0 and 7, inclusive of 7. So you got to watch out. So what integers are greater than 0 but less than or equal to 7? 1, 2, 3, 4, 5, 6, 7, right? So the cardinality of this set is 7. Another definition, we say two sets A and B are equal, simply means they contain the same elements. They contain the same elements. Now note, the elements do not have to be in the same order. Sets do not have order. So here's an example. Can you answer the question? Are these two sets equal? Then let's see. Both sets contain a 1. They both contain a 2. They both contain a 4. And they both contain a 7. So they do contain the same elements. So yes, they are equal. Now, a slightly different definition here is the word equivalent. Equivalent simply means the two sets have the same number of elements. They can have the same elements and be equivalent, but they happen to be equal. So you can have sets that are equivalent and equal. You can have sets that are equivalent but not equal. In other words, these two sets above here are actually equivalent because they contain the same number of elements. They also happen to be equal. So just because something's one thing doesn't mean it can't be another. Here is an example. Well, this is what we just went over. We have a set A. We have a set B. We're asking if they're equivalent. Equivalent only requires they have the same number of elements, which they do. So our answer is yes. Given the set C and the set D, are they equivalent? Set C contains 4 elements. Set D contains 4 elements. And so, yes, they are equivalent. So now we're going to get into some ALEKS type problems. Read the above description of a survey we completed. And based upon this survey, we're going to determine whether or not the following statements below, right here, actually represent sets or not based upon what information we gathered from the survey. So again, I suggest you pause the video and try to answer the 5 descriptions to determine if they're sets or not. Okay, I'm going to get started. Now, the set containing the drama most watched by women and the drama least watched by men in the Friday night lineup. We know we're working with a Friday night lineup. We also determined the sitcoms based upon 3 groups, men and women. So we divided up between men and women. And the 7 shows were identified as either a drama or a sitcom and ordered from most watched to least watched. So we can determine if it was a woman or a man. We also can determine whether or not it was most watched or least watched because we gathered that information. So this one is a set. The second one, a set containing only the show in the Friday night lineup with the worst dressed actors. If you look at the survey above, we do not even address that statement in our survey. Nowhere up here do you hear anything about the survey finding out if people consider them to be a worst dressed actor. So that is not a well-defined set. The set containing only the show in the Friday night lineup with the worst cast. Did we collect the information in terms of having the worst cast? Sorry. All right, this is an unedited video. I don't edit my videos. You get what you get. All right? Okay? Just keep that in mind. All right? I don't take time to edit here unless I really find a big mistake. All right, well, anyway, I don't see that information, anything about collecting about what we would consider the worst cast, so that is not a set. The 2 least watched shows overall in the Friday night lineup. And we did gather that information, the 2 least watched shows, right? Because we ranked them from the most watched to the least watched. So a set. The set of the last 3 shows to air according to the Friday night schedule. The set of the last 3 shows to air. So did we track them? Yes, television airs 4 sitcoms and 3 dramas on a fixed schedule. Okay? That's the Friday night lineup. So we did collect that information, and we should be able to determine which three shows were airing at the end of the night. Again, I suggest pausing the video, trying to work the problem out, and then restarting the video. So, what we have here is a table where we collected some information. It tells us the number of customers that individual servers served during lunch and dinner. So we collected the information on who the server was and how many people they served at lunch and served at dinner. So, give the set of servers who served more than 25 customers at lunch. And we want to use roster notation. So, those who served more than 25 customers at lunch. Well, if you think about it, Ann served more than 25. Bob did. Juan did. Yoko did. Chow did. Lucy did not. Maya did not. And Trey did not. So our set would consist of, well, I didn't put it down there, but here it is. Ann, Bob, Juan, Yoko, Chow. And there is my set with some of the worst looking curly braces you can imagine, right? The second question again, pause the video and give it a try. We want to come up with a set of servers who served more than 70 customers at dinner. So now, more than 70 at dinner, Ann did. Bob did. If I go down the list, the only ones I see is Ann and Bob. So we'll close our curly braces and get rid of that extra comma. So there we go. Here's our next problem. I suggest pausing the video and trying to answer it, then play the video. We're given a set in roster form here, and we would like to describe this set. Now, when I look at this set here, what I see is the natural numbers that are at least equal to 5 and that are odd. 5, 7, 9, 11. So let's just go down the list. Positive multiples of 3 that are less than, no. 5 is not a multiple of 3. The set of odd natural numbers greater than or equal to 5. They're odd, they're natural, and all of them are greater than or equal to 5. So that one would work. The set of odd natural numbers, no, because one that's missing is 3. 3 is an odd natural number. The set of natural numbers greater than or equal to 5 and less than or equal to 11, no, because we have our 3 dots here, and that means we keep on going, repeating the pattern. Our second problem. Pause the video. We are given the set of natural numbers greater than or equal to 5 and less than or equal to 8. So be careful. Greater than or equal, less than or equal. And we want to list this in roster form, meaning we need to list all the elements. So we know we're going to start with 5. Since we're working with the natural numbers, we're going to choose 6. We're going to choose 7. We're going to choose 8. But we're going to stop because we have to be less than or equal to 8. Notice I use these fancy looking curly braces, and I also separated the elements with commas. Once again, read the problem, pause the video, try it, and then restart the video. We want to write each set in the indicated form. If necessary, use the 3 dots to indicate our pattern, and you really should use at least 4 elements to help identify the pattern. All right, so we're given a set builder form where x is any natural number that is larger than 2. So the natural numbers larger than 2 start with 3, followed by 4, then with 5, then with 6. We have identified, or at least helped to identify the pattern. So at this point in time, we can put our 3 dots and then close the curly braces because x keeps on going. Look at part B now. Again, if you haven't worked it out, pause it, then watch the video. We're given a set in roster notation. How would we describe this in set builder notation? Well, our numbers are natural numbers, so each one of these is actually satisfied. The numbers are the natural numbers that are between 11 and 15. Another way of saying that is between 12 and 14 inclusive. So I see number 1 working. Number 2 don't work because we have to be at least 12. Number 3 doesn't work because we have to be no more than 14. And for our last one, we have strict inequalities here, so it can't be that. Once again, pause the video, try the problem, play the video. So we're given 2 sets here, A and B, and we need to find their cardinalities, meaning we're going to count how many elements are in each set. For set A, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 elements in A. For B, the set's being described, so we better be careful here. There are odd numbers greater than 3, less than 11. So the B actually looks like this, and this is what you really should do. Odd numbers greater than B, 5, 7, 9. But we have to stop because it has to be less than 11, and our next number would be 11. So B consists of 3 elements. Be careful because when someone lists the elements using roster notation, if an element is repeated, you only count it once. So be careful, but I've yet to see that happen in ALEKS. Pause the video, try the problem, play the video. We have 2 sets here, set A and set B. And we're just trying to decide which of the following best, I'm sorry, I set the check mark here, which of these best describes the relationship. A is a set of integers that are greater than 5, less than 9. So it might help by actually showing what A is. 6, 7, 8. Because they're greater than 5, less than 9. Now, are they equal? No. Are they equivalent? No. Because equal means the same elements, equivalent, the same number of elements. So they're not equivalent, they're not equal, they're not both, they are neither. So neither is our answer. Let's try a second one. Pause the video, try it, play it. Here are our 2 sets. Now, are they equal? Well, A, 92 is in both of them, 93 is, 94 is, and 95 is. So they are equal, and they also are equivalent. Why? Because they have the same number. So equivalent but not equal? No. Equal but not equivalent? No. Both equivalent and equal? Yes. And we know the other one is not correct either. Okay, read the problem, pause the video, try the problem, play the video. So you've read it over, you know what it's asking for. We need to answer the following 3 questions. Choose a set that is equivalent but not equal to the set of Wilton's amenities. So we want it to be equivalent, meaning the same number, but not equal. So here's Wilton. It has 2 elements. So let's look for another set that has 2 elements, Queen. And it's not equal because the elements are not the same, so Queen. B, choose a set that is equal to the set of Keen's amenities. So here's Keen. We want them to be equal. So if we go along looking here, we know Queen can't be. We know Lacey's not because Lacey has trail, Keen doesn't. Going down, did you notice Golden, Velodrome matched up, Park matched up, Stadium matched up, Aquarium matched up, and Mall matched up. So Keen is equal to Golden. Find 2 cities whose sets of amenities are neither equivalent nor equal. Well, you just need to grab 2 sets that have different number of elements. So Queen and Lacey, they're neither one. Lacey and Seaside, neither one. Queen and Seaside, there's a bunch of different combinations you could come up with. You just need to find 2 which don't have the same number of elements. You know it can't be equal then, right? Well, that's all, folks. This is the end of this first video. I'm working on the second video. Hopefully it's out there almost as fast as this video got out there. But just let me know if there is a mistake. Please let me know. Again, I do not edit my videos. I'm doing this as a favor to you to help you out. So again, just let me know if there's an issue or a question. Thank you very much.